Cool. Thanks. I'm Yehonatan Daniv, but we'll talk about me later, because I know what you are thinking, right? So, we're almost there. It's kind of hard giving that last talk before lunch, as you can see. So, a common trick to get the audience attention just before lunch is to ask them to raise their hands in answer to questions. So, let's practice this once, shall we? Who here knows what's that star on the left? Cool. And who here knows what's that place on the right? Okay, thank you, hands down. So, this is Cybertron on the left, and that's Easter Island on the right. So, can anyone think what could be the connection between the two? Okay, we'll get back to them. Please raise your hand if you're a front-end developer. Cool. Now, keep those hands up. Thank you. Up, 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 up. Now, if you're not working on a user-facing code base, you can lower your hand now. Okay, if you haven't deployed any code to production in the last month, you can also lower your hand. Okay, now look around you. Now, divide the number of hands here by the people who actually raise hands in conference talks. Okay, now, as you can see, this is some estimation of the amount of code that we added to what our users have to download just in the last month. Okay, hands down. So, back to Cybertron. Can you think any clue what could be the connection between the two? Almost. So, both the Transformers, the people of Cybertron, and the Rapa Nui, the people of Easter Island, had to leave their home because they had run out of all of their resources. What's our resources? Ours is performance, accessibility, SEO, or in short, user experience. As long as our user's experience is perfect, we can do anything. Our company's resources is our time, developers' time. As long as there's enough dev hours, the company can do anything. The thing that's taking most of our resources is our code. Our code is our power, but it comes with a great cost. With more JavaScript, we have more bugs, for sure, more complexity, less dev velocity, less dev time, less performance, because it blocks rendering, delays input, and it's mostly less accessible, so it's worse user experience. Now, I'll explain this very deep and very nerdy metaphor. Our planets are the apps we build, and our population is our code. This graph was taken out of the CWV Tech Report. It compares large websites with enough traffic that are built using different frameworks, libraries, and platforms. It compares about 10 million sites with their real user data, core web vitals data. This specific graph compares Wix as a platform to all the others, frameworks and libraries. We can see three things here. One, the median of the amount of JavaScript that we transfer to our users on Wix websites is 1.5 megabytes. Two, it's much higher than the median of all the others combined. And three, it's growing at a higher rate of all the others. So you could say we are heading towards a non-sustainable state of overpopulation. Now, I'm not here to offer any new JavaScript tricks and not any new framework. If there's one thing, I want to talk today about one concept. If there's one thing that you take with you today from this talk, is this. The web platform. It's a thing. It exists. It's real. What is the web platform? So, it's everything that we use in the browser. Everything. These are the three main browser engines that we have today: Blink, Gecko, and WebKit. All open source projects, all follow the same standards. Everything we use is the web platform. Technologies like HTML, CSS, SVG, JavaScript, WebAssembly. Technologies like APIs like storage, navigation, geolocation, IndexedDB, WebGL, everything. But the web platform is not only for external APIs like USB, GPS, and file system. Web platform also gives us ways to do the things that we build in our everyday features, like creating layouts and reacting to user interactions. Let's see an example. Popovers, menus, tooltips, floating panels. We have these all over in our internal apps, on our user-facing apps, and on users' websites. To build these components, we use plenty of hacks. We add extra elements, CSS hacks, we do special DOM nesting, we add a whole lot of JavaScript. What do we have here? We have Z-index hacks to keep content on top of other content, special nesting to position elements. We have extra elements for dark overlays, and extra event handlers to dismiss them using clicks or hitting the escape key. We can remove all of these hacks and a whole lot of code if we use, that's right. More specifically, if we replace all of these hacks and the custom code with the native popover API and the anchor positioning API. These are relatively new APIs we can use today in HTML, CSS, and even in JavaScript. They come with all the features we need, accessible, already tested, and they're performant. And it's that easy. You just replace all of that code with a few lines of HTML, CSS, and you're good to go. So, if I still haven't convinced you that this is worth your time, let me show you an example of how my team applied this method in one of our projects. So, Wix Motion project was started a bit over 2 years ago. Rebuilding all of Wix's animations, infra, and products from scratch. Wix's animations were built on top of the GreenSock animation platform. It's short for GSAP. It's a JavaScript-based library. Yes, the same library that was recently acquired by Webflow. Webflow acquired GSAP, and we're completely removing GSAP. Webflow continue downloading 40K of JavaScript they now have to maintain forever, and we're downloading 0. What are we using instead? Anyone? That's right, and more specifically, the Web Animations API. What's good about it? It's written in C++, it's already compiled, and it's already installed on all of our users' devices. It's 0 bytes to download. Now, with this rewrite, we got 75% less code to maintain, 75% less code downloaded by our users, and needless to say, it's much more performant. Like that. Here's a profile recording that we took of a scroll effect in our playground with the old system, and here it is again using the new system. Thanks. Notice the scripting is 12 times smaller using the new engine. OK, you'll probably say that's easy peasy. You just remove an external library and replace it with native API. So what? OK, I also promised you the future. How can we see into the future of the web? Well, we need to understand how features on the web platform come into existence and where. So the W3C, short for the World Wide Web Consortium, is the organization in charge of most of the standards that specify the web platform. It's made out of different kinds of groups. Working groups are the ones that write specifications, or specs in short. Specs are where the features are born and come into the web platform, and the W3C groups is where that happens. In the beginning of 2022, we joined the W3C as a member, and I joined the working group, CSS working group, on behalf of Wix. That's a bigger picture of me. I'm Yehonatan Daniv. architect at Wow Company, there in the back. 7 years at Wix, 3 years in the CSS working group, and Wix AC representative for the W3C. Now, back to Wix Motion. Here's an example how we pushed the limits further and worked on making the future happen. So one of the products we built as part of Wix Motion is the mouse parallax effect. It allows our users to attach animations to mouse hover interactions, creating these gorgeous effects. This is currently done using JavaScript, and that's OK for now. But that's not zero code. Still, there's a lot of code to maintain, test, build, and download to the client. So it was good enough to create and release a new experience that we couldn't do natively. And we knew that we want to have this using CSS. So if we want to delete all of this code that we wrote, we have to do some inception work. We need to plant that feature, as we designed it, inside the apps that are already installed on our users' devices to be part of the browser engines, part of the web platform. Okay? So this is how we used our participation in the CSS working group to shape the future. I presented a proposal for a new native pointer timeline for creating these mouse parallax effects natively using only CSS. This was presented to the CSS working group and accepted earlier on September. And members from Google, who are also part of the group and took part in that meeting, are also very interested in implementing this. So this feature also has something that's called vendor interest. Okay? That means that a company that builds one of the major engines is also willing to ship this one day. Another example of shaping the future is how we trigger time-based animations. Today, they are triggered using JavaScript. This code is a bit complex. It allows very limited set of features because of technical limitations, and it can easily collide with other features. So I've made a proposal for a new animation trigger API, so animations can be triggered using CSS. This was also approved. I've written the first draft of the spec. And again, Google are very interested in this one too. So this is how we build for the future web. We designed everything to either work natively with what we have, or that we can later completely delete it and replace it with native features. CSS in these cases. Now back to Wix. How can all of us build for the future web? So let's go together through the journey of how features become part of the web platform. You don't have to remember all of it, just to give you general pictures of how features enter the web and become part of the platform from an idea into an actual feature. So they start as a proposal issue on the working group's GitHub repos, sometimes even as a written explainer. The proposals are discussed in GitHub and then later inside the group. Then they agree to do it or resolve on adding it, and then someone from the working group will write the spec. Then we need an engine to agree to prototype it. And when that's ready, they'll probably ship it and write about it in their blog. And when they write it, they also write tests. Tests for the entire web platform go on the web platform tests project. After we have tests for all the engines to fail, we can ask them to kindly get their business together and pass the tests. And if they agree, it goes on the interop project. This is where they have 1 year to join the party. And then, after all browsers are aligned, we can say that this feature has reached baseline. That's the baseline project. And you can see the results of all of this on the documentation of the entire web platform, which is on MDN. Now, all of these are open and available online, so you can know what's coming and see what we have both in the present and in the future. So, now you know how to look out for stuff. But how do we use that knowledge? So, the main thing that you put into your process is an iterative step of research. What do we research? You know. That's right. We don't use development until we've done enough research to get a clear path for a future-proof design. That means solution without hacks and zero JavaScript in the client as much as we can. Whatever and wherever we can't use something today, we write code that we can later delete, like polyfills. Now, my team does it by building a prototype as we do our research. We create a quick, minimal prototype for the solution, vanilla, outside of Wix, that we can get a clear technical path. So, now you have the knowledge of where and the tools for how. And to sum it all up, use the web platform. Start off with a vanilla prototype. Do your research until you have a clear technical path. Aim to reaching zero JavaScript in the client, and no hacks. Use what you can, native. Polyfill what you can't, and if you think there's something that should be native, try proposing. And as always, if in need of help, assistance, or guidance, you can always contact your local W3C representatives. Now, my team has a booth outside. Look for the WOW company. We show cool stuff, we give away prizes, we answer questions, and we're also hiring. Now, go forth and delete code. Thank you.